Thank you, Pam. All right. So for those viewing online after the fact, good morning, welcome, and we'll go ahead and jump into our coursework and with Jennifer Rennick.
Hi, everyone. Welcome. For the recording, just a reminder, I'm Jennifer Rennick. I'm a licensed architect and a certified energy analyst, and Andy Pease is here with me, also from Balance Green Consulting. We are code coaches for the rural REN, and Andy Pease is also a lead accredited professional and licensed architect. Andy is going to monitor the chat. He's also going to jump in on a couple slides here and there, or field questions. If you have questions, put them in the chat. She'll stop me. Otherwise, we'll do questions and answers at the end. And with that, I'm going to get started on kind of the historical context of why California has an energy code. And we've found that when we do the introduction and start talking to people about the energy code, a lot of folks are not familiar with sort of California's history and why we have such a robust energy code and such a robust process for implementing an energy code, which set the stage, kind of set the example for the rest of our country. But back in 1973, we had a national energy crisis, and we had what was called the oil embargo. And the U.S. was very dependent on OPEC oil, and there was a crisis from limited supply of gas. So gas stations, pumps were closed, prices were extremely high, comparatively speaking, compared to what folks were used to paying and the income people had. And so this embargo really set the stage for people to change their attitude towards energy. And so people started to drive slower. This was when the 55-mile-an-hour speed limit first got introduced in California. It used to be a lot higher. I can't even imagine driving so fast in the cars that look like that, but people did. I guess I did too as a little kid. Oregon turned off all the hot water to state buildings, for example. Jimmy Carter had everyone put on a sweater. They said they're going to conserve energy instead of turning up the heating thermostat. And he had solar panels put on the White House roof, which then later got taken down under Ronald Reagan, but it set the stage. And in California, as a whole, we started to address kind of what was California's energy future. And so a very smart group of engineers, scientists started to look at where our energy went in California and what we could do. And they realized that if we could conserve energy in terms of how we produce energy, how we make electricity, how we send it to our buildings, and the fuels we're burning in our buildings, if we could conserve that energy, they were able to show that it would save the state an incredible amount of money. And the state moved forward with that legislation to do it. And so the graph on the left shows kind of what the rest of the country did, but what California did in terms of conservation. And then through that conservation, California has been able to avoid building many more power plants, saving our state millions and then billions of dollars. So even though our population in California was growing, our energy use per capita remained relatively flat, and it continues to this day. So the energy code was kind of born in 1978, where they said, let's implement this into our buildings standards. And then they started to figure out how they were going to have a process. And over the decades now, we've built up a process where we now are targeting, for example, in 2045, 100% carbon-free electric generation. And then along the way, we had a new code introduced, Cal Green. And so Cal Green was tagging on to the work done on the energy code, but was also hitting on a lot more other issues involved with buildings that address other sustainability and other measures to save energy and make it easier to implement the ability to use less energy in our buildings that weren't exactly tied to the energy code. So it supports the energy code in a lot of ways. And then we, bring it up to more current times. We've had a number of code cycles. We're now in the 2022 energy code cycle. And then coming up this January, we'll be in the 2025 code cycle. So California has made steady progress in setting these big goals. So California, for its planning for its future, if you haven't read this document or you're not familiar with it, it's available on dov.ca.gov, and you can read a little bit more about how California has its transition plan, because it does include the transportation sector and zero emission vehicles. It also includes the industrial sector, and they're working on ways to have clean electricity, but also clean fuels, such as green hydrogen. And the whole thing behind green hydrogen is you use renewable or solar energy to create the hydrogen, therefore green. And it is a different use for our natural gas supply. And then part of all of that is the code, energy code, kind of in general, is embracing going all electric or nearly all electric for a lot of our building types. And so new construction now, if it's small scale, it's really fairly easy to go all electric. And then there are a few exceptions with really large scale buildings and industrial applications, but that's where some of that green hydrogen comes into play. And then the energy code hits on existing buildings as well, in terms of when there's HVAC replacement or remodels and additions. So part of that is there's opportunities for improving the building itself. Maybe you add solar batteries, but that's kind of addressed in the code. And then there's, for going all electric, we need to support the infrastructure. So there is a whole discussion on existing communities and what we can do for those existing structures and the whole existing neighborhoods, and look more at having our electricity produced in a way that is less impactful and just support electric transportation. Right now in California, to kind of set the stage for that, so I'm trying to give you like this big picture of where California is. When we produce electricity in California, we are at a point now where about 69%, now it's a little bit more, come from non-fossil fuel sources. So wind, hydroelectric, nuclear, and we will have a certain portion of our electricity, though, is still produced by burning natural gas in natural gas power plants. These are often referred to as peaker plants. And these peaker plants are often operating during 4 p.m. to 9 p.m., which is when Californians, we get home from work, it's starting, especially in the winter, it's dark out, all the lights go on, people are cooking for their family, they're doing their laundry, you name it. It all seems to happen a lot from 4 p.m. to 9 p.m. The sun isn't shining, so we don't have as much solar. So we are firing up natural gas power plants to produce that electricity. But as we transition to a clean energy grid, we're starting to put batteries, large scale batteries, to take in the extra solar energy we're producing during the day and store it up to then release that energy during this peak time of day so that we don't have to depend on burning fossil fuels as much for our electric grid demand. So because of that, these are standards, all together, everything that California is doing, and with the new standards coming up, California has estimated that we're going to save the state $4.8 billion just from not having to build new power plants and not having to create more energy infrastructure, but we are needing to upgrade the energy infrastructure so that we can have more electric ready buildings and more electric buildings and electric transportation in general. So the big picture goals for the energy code is to improve that air quality through clean energy production. So part of it, and you get down into it on the building scale, is to encourage heat pump technology. It's just more efficient way of producing space heating and water heating. We're going to have electric ready requirements. In other words, you can still have fossil fuels or natural gas in the building, but you need to set up the infrastructure so that you can switch to electric appliances when appropriate. Going to expand the PV and battery storage standards. And there is also what's called an energy water nexus, where the more water you use, the more pumping energy gets used and the more water processing energy is used. So California is continually looking at ways to save water and then save energy. And then coming up in the 2025 code, for example, there's language that addresses chillers for large scale buildings to save water, which also saves energy. Okay, so that's kind of the big picture sort of context of why we're where we are in California. And then when it comes down to California's energy code specifically, and I see that a lot of you, so sidebar, I noticed in the chat a lot of you have some background already with codes and standards. So that is great. But just in case we have a couple folks on the call who are really brand new to this, I want to remind everybody that the California Code of Regulations exists, and we have 28 titles. It covers, roughly 200 regulatory agencies. And of these 28 titles, the ones we're often dealing with in our line of work is Title 24, the Building Standards Codes. The Energy Code is a part of that. We also a lot of times have to deal with Title 25, which has to do with housing community development for pre-manufactured homes. So we'll hit on that briefly at the end. And then Title 20, that'll kind of pop up on a few of the slides. And Title 20 is where we talk about the energy efficiency and energy efficiency testing for the appliances that we use in our homes and buildings themselves. And there's also the small scale heating and cooling equipment often used in homes falls under Title 20. But these three titles talk to each other. Main one, though, Title 24, are building standards codes. Then within that, we have Part 1 through Part 12. And if you're doing residential work, we also have a Part 2.5. So Part 6 is the energy code. Often shorthand, we just call it Title 24, but there's a lot of parts in Title 24, and a lot of times we're only talking about the energy code. Somehow Part 6 got shorthanded to Title 24. Don't ask me why. That part I don't remember, even though I probably was doing architecture then. I don't know. Okay, but part 2.5 is the California Residential Code. There's, in other classes, we talk about this, but there is reference back and forth between these codes. However, just as a heads up, for those of you who are in the plan examination world and you're reading those code books, there's California Residential Code refers to climate zones that are ASHRAE. Energy Code, we use our own climate zones, which I'll hit on in a slide. So just kind of keep that in the back of your mind. We do have that come up a lot as code coach questions because it does lead to some confusion. And then part 11 is the California Green Building Standards Code. So those are the three that we're mostly kind of touching on for energy code related work. Of course, all of them play in, especially, mechanical, plumbing, electric is obviously related. Okay, now coming up, part 7 for a long time was vacant. In 2025, it's now going to be the Wildland Urban Interface Code. So just give you a heads up on that. Through a contract with Westlaw, all these titles can be found on Westlaw's website that they set up. You can click on, the Title 20, the Title 25, and get that reference. When you do click on Title 24, however, it's the only one that kicks you back over to a different website, and it's going to take you to Building Standards Commission website. And there you will get the link to the Title 24 part of all of these codes. And just as a reminder, the new 2025 code is coming up. And once you click on that, then it'll kick you into which edition of Title 24 you want to go to. Click on that link, the whole thing expands out, and now we're back to, the part 1, the part 2, the part 2.5, etc. for each of the codes, including the errata and supplemental support. And then for part 6 specifically, the energy code, when you click on that, then it'll take you to the ICC website. So you can bypass all this and go straight to ICC to get that code. But I also wanted to just show you, in case any of you are new, to just how, the state has kind of organized this. So if you do go into that ICC webpage, there you'll be able to get a digital version, either basic or premium of it, or you can order a printed version. Now, the code itself, you might have noticed that when we were going through those slides, there were different versions. I showed a little graphic representing like the 2019 code, then the 2022 code, 2025 code is coming up. From looking at the chat, probably most of you realize that our code changes every 3 years. But just in case, I want to remind everyone that we are on a triennial cycle. So the new code is going to come into play January 1st, 2026. And there is a process and pre-rule making process, and then a formal rule making process. And for the 2025 code, we have gone through that, and now we're in the process of getting all the documents published and the software that we can use for the energy code approved, and everybody's marching towards this January 1st rollout. And then with the energy code, there are many manuals available in addition to just the standards. So you can get the standards like from the ICC website that's in the same format that the rest of the building codes are set up. But the California Energy Commission has kind of the jurisdiction over the Part 6, part of the Energy Code. And they publish their own sort of formatted version of the energy standards. And then with it, those standards point to what's called the reference appendices. It also has points to the calculation methods that are required for the software that's used with the energy code. And then there's also companion manuals, both for the non-res multifamily and then the residential family. So those manuals are very useful resources because they'll take part of the language of the code and they'll walk you through like how to problem solve or commonly asked questions. And if you're really wanting to learn the energy code and then say, be an expert in the energy code and become a certified energy analyst, then like these manuals will be some of your best friends, for example, because they take you through a lot of common questions. And then as a heads up, for 2025, we're going to have another manual that specifically deals with data registry requirements, which probably, you know, if you're kind of in that HERS world or the home energy rating program world for part of the code compliance process, then that manual is going to address some of those issues, but more specifically for the entities that register our Title 24s, which is another piece of the process. We'll kind of hit on that. So kind of back up, bigger picture again on the energy code in terms of what's then really covered in the energy code. So when I talk about that energy code, I'm talking about building envelope, meaning your floors, your walls, the windows, the roof, the hot water the building uses and how much energy is associated with that, the heating and cooling and the fresh air ventilation systems, lighting, so your building scale solar energy and battery systems, and then the field verification and diagnostic testing. So the image on the left, that's one of our local HERS raters. So I was on site with them and we were looking at how the insulation was installed. And so having a third-party entity come and look at these things in our buildings is also part of the process. And that is part of that HERS data registry also I was talking about. And then there's covered process loads like refrigerated warehouses, controlled environment, horticulture, elevators are included in this. And then sort of the things that are not included was what I was saying was covered under Title 20, and that would be your household appliances, really small scale, like residential scale heating and cooling systems, the efficiency of that heat pump you might use in your house, all that testing falls under Title 20, but also walk-in coolers and freezers fall under Title 20. And then refrigerated warehouses under 3,000 square feet are not part of the energy code, and temporary structures or ag buildings are not part of it. Okay, and then as a kind of like a little sidebar, and well, it's related, I'm going to hand over this portion to Andy because she's going to talk a little bit kind of about the process. So that's kind of the bigger picture of overview of the energy code, but then really when and where does the energy code show up in the process of design and construction? And he's going to hit back on that. And then I'm going to dive in deeper to the energy code itself.
Awesome. Thanks, Jennifer. And thanks for folks who've chimed in on their backgrounds and their organizations. It's great to have everybody here. So there's traditionally been that linear approach to design where you have an architect, and even within that, there might be solos where the architect just kind of hands over base plans And then everything gets into a plan set and goes to a plan checker and a builder and an inspector, and we don't end up with kind of the continuity. So we find that the inspector at the very end is kind of stuck because maybe the insulation thickness in the roof doesn't meet the energy compliance, but that's because the framing members weren't sized to meet the energy compliance. And so the builder didn't have it on theirs, and the plan checker didn't spot it, and the architect hadn't noticed it because things were not done in a coordinated way. So we're really working to talk with folks about that integrated approach to design, so that we can identify early on all those nuanced requirements of both the energy code and Cal Green. And it starts with kind of this cycle throughout the whole process. Some of this is going to align with commissioning, building commissioning, where for non-residential buildings that you start with kind of a program requirement. But no matter the building type, with the owner, you're going to be starting with what the owner wants and really understanding kind of from a performance level, what kind of controls they want, what levels of lighting they want. All of those pieces get communicated to the design team, again, hopefully through an integrated approach. And the understanding, obviously all the design professionals, everybody in the room knows that there's a whole, that all those sections of Title 24 need the analysis, code analysis to know, but making sure that that energy component comes in early enough for energy and Cal Green. Goes to plan review. Again, we're trying to work with architects to not have them just report to a Title 24 report, but make sure that that information is on the building plans, to the point where like those verification measures, maybe they go on the title sheet rather than kind of being buried with refrigerant testing or something like that, so that nobody gets burned at the end. And then the contractor really knows what's going to be required in terms of those design decisions. Then you're kind of set up in a good position where the verifications just pop along, everybody's happy, you get your sign-offs, and then we have the happy owner at the end because they got what they asked for up front. So that's kind of a process that we hope wherever you are in that point is that we just are reminded that the earlier the better to involve the energy team into your project. Anything that I missed, Jennifer, that you want to make sure gets touched on here?
Just as a kind of a heads up, HERS raters, the home energy rating system, is what HERS stands for, and that was that slide. And just for 2025, just kind of a warning for everybody, that HERS rater in the 2025 code is now going to be referred to as an ECC, Energy Code Compliance rater. Just there's a new change in vocabulary, and believe it or not, a lot of those HERS things were under Title 20, and now it's pulled back over to Title 24. And that's just kind of a heads up because this code's rolling out in January. So you might, be learning one thing now about the energy code. And if you're new to this stuff, then in January, you're going to see something else. And I just wanted to give you all a warning about that.
Yeah, thanks, Jennifer. I forgot to mention that. And then the HERS is also very inconveniently is also a national program that has a home energy rating system, and it's a private, I think it's probably a nonprofit, but it's a private program. So it has been confusing for folks who are working in California and outside of California. So to move away, there's kind of just the logistics of putting it in the Title 24 instead of 20 and having some clarity there, which is great, but also the renaming, I think, is really good. Overall, I think that's going to help clear up some confusion for folks who work in and outside of California.
Yeah, thanks. Okay. Energy code. So now, if you are relatively new to the energy code, we're going to go over some details in this. Also, some of you are familiar with this a bit, so I did include slides of just a heads up of big picture things that are going to come up under the new 2025 code, so you're just aware of it. But right off the bat, I want to remind folks that the energy code, there's kind of three key things to keep in mind as you read the energy code. And one is that there are mandatory requirements which are applicable to all projects. And those are energy efficiency measures that everyone has to meet. Okay, that's one thing. And then you can comply with the energy code using a prescriptive component package, or sometimes you just hear it, you could comply prescriptively, and the mandatory requirements are still applicable, but now you follow the prescriptive requirements, and it's essentially following a checklist. And then the other way you can show compliance is through what's called the performance method, or computer modeling method, or energy modeling approach. You'll hear those words interchangeably. And this is where the prescriptive component is treated as your standard design building. And then that standard design building is compared to your proposed design building. And through this energy software, you can show, if you can show that your proposed design is more efficient than the standard design, then it gives you the flexibility to design the building the way you want to. So most of our work is doing the performance method because it gives the whole design, build, development, ownership team the most flexibility to be in control of what they want in the building and their costs. But they just need to show that the building's not going to use any more energy than a standard design. Also unique to California is we have 16 climate zones, which I kind of alluded to that comparison in the, when you look at the big picture of Title 24, 2.5, it's based on the international code. It's applicable to California. It was adopted here in California, but it references the ASHRAE national climate zones. But when you get to the energy code, it's going to be very specific to California's unique 16 climate zones. And where you find out more about that is in those joint appendices that I mentioned, not in the standards language itself. And then the ECC has an online tool called the EZ Climate Zone Finder, and you can hone in on your climate zone through that website or look it up by zip code if you don't have a copy of the reference appendices standards. The energy code also has a unique organizational structure. It's organized differently than all the other parts of Title 24. So I find it helpful to show people what this structure looks like. And subchapters 1 and 2 really deal with all of the occupancy types. And currently, those occupancy types per the UBC, per the Uniform Building Code, we have, A for assembly, we've got B, our business office, etc. So those occupancy types are all addressed. And then there's 3 buckets that the energy code is broken up into. We've got our single family residence, which includes duplexes and townhomes. Multifamily, both high rise and low rise, has its own sections. And then everything else that's not residential are the other subchapters. And you're going to get a copy of the slides. So this is here for your reference, so you can see it for those of you who are more visually oriented, which I am. So I appreciate it kind of pulled apart like this. Just kind of a little heads up, in 2025, we've added an occupancy group now to Title 24, L for laboratory. So just kind of a FYI for folks who are getting into the code. The code itself then has all those subcategories. And so in the standards in subchapter 1, there is a table called Table 100A. It's useful for understanding more where to find the parts of the energy code that you're looking for. And it's set up where they list the occupancy in the left-hand column, then give you an idea of what that application is, whether it's an envelope measure, pool, spa, solar ready, etc. Then it lists the sections that have those mandatory measures we talked about, your prescriptive approach, like the checklist, or the computer or performance energy modeling approach. And then there's also, they call out the section specific for additions and alterations, because a lot of times additions and alterations are nuanced, and so they have their own requirements that are going to be different than the new construction prescriptive or the new construction performance. But they often refer back to those others. So, for example, if we wanted to look at a single family occupancy type, and we were interested in the envelope, and this means the conditioned space, so something about the walls, the floors, the roofs, etc., we would go to these sections for the mandatory measures, and then we would be able to go to this section for prescriptive, kind of understanding our baseline and understanding the performance. And then, of course, we could go to 150.2 if we were doing additions and alterations. And then just kind of taking this as a theme, I'm going to use the single family residence and just show you more how that code is broken down. And this again is in the standards manuals where you'll find it. So the standards manual is going to spell out what's required for single family homes. And here's those 3 chapters, and kind of expanded out what each of those 3 chapters cover. The first chapter, section 150, or chapters, subchapter 7, is those mandatory measures, and everything that is applies to A through R. So there's quite a bit there. And then subchapter 8 is your performance and your prescriptive. So that's specific to new construction. And you can show compliance using that checklist approach, prescriptive approach, or computer performance modeling. And then subchapter 9, we've got additions and alterations. Again, this is for existing structures, and you can also show compliance prescriptively or the performance method with those. So if we were to take a look at wall insulation, for example, and we're looking at performance prescriptive, it's under the building, envelope. We're going to take a look at that, and we're going to look at what do we need to do for a prescriptive requirement. In the end, we might take it and use a performance method, but this way we know what our baseline is going to be for the walls itself. And then when you dig into the energy code, it could be a little overwhelming at first if you're new to it, because there's a lot of tables like this, and a lot of language. But I'm going to walk you through an example. Let's say the project's in Monterey, so climate zone 3, or maybe we're in San Joaquin Valley near Visalia, would be climate zone 13. And we're interested in looking at what's required for wood framed walls prescriptively. We can do trade-offs under the computer method, but we'd enter the table for climate zone 3. We'd go to our walls, they're above grade, they're framed, and then we're given a U factor or a U value. I'm old enough, I remember we call U values, U factors. I say the word interchangeably, but you'll see the trend now is just to stick with U factors. So that U value, I'm calling value, is 0.048. Ugh, that number, if you're not familiar with this part of the building code or what these words mean, is it's an indication of heat transfer through that wall assembly. And there is some math that goes to calculating it. However, we're able to go into the reference appendices and just basically look up what does a 0.048 U factor mean? You know, something that's useful to people in the field and architects and designers. We're going to do the same thing for climate zone 13. It happens to have the same value, so 0.048 U factor. So, you know, we got the requirement out of the reference. Got the requirement out of our standards language. Then we could go to the reference appendices to find out what that U factor really translates into. And in this case, I created a table that I thought was easy to understand, but there are tables in there specific for each kind of building type. It's organized a little different in the reference appendices, but what it basically refers to is you have a wood stud wall, how much cavity insulation do you need? And then do you need exterior insulation? So for U factors, how they work is you need something that is 0.048 or less. So the smaller the U factor, the more insulative. Smaller, better. So we have to look for numbers that are less than 0.048 or equal to 0.048. So it turns out for these climate zones 3 and 13, you could have a 2x6 wall and fill it with R21 insulation and put an R5 exterior continuous on it. That would be one solution. And so there's a variety of solutions, but this is how you comply prescriptively. And a lot of times what happens is we'll have a client say, I don't want to do it that way. I would rather just use a high density bat in a 2x6 wall, no exterior insulation. And the answer is you can do it. The U factor is bigger. So then we have to do a computer modeling method for the trade-off. And then the compliance manual is like your best friend if you're new to the code, because it helps you understand that and go through some of the process. So here's an example for, like a non-residential project. Let's say we've got a 2-story commercial building in the Visalia area, so climate zone 13. And the design team is trying to figure out if they're going to use metal stud walls, but they might use wood stud walls, and they're trying to figure out what the implication of this decision is. And so again, they can take a look at go into the standards, find out what the requirement is. Then you look up what is needed for an opaque wall, wood stud, metal stud, have the comparison. And then those reference appendices are going to give you the clue on to what that translates into in terms of a structural assembly. So it could be a 2x6 stud wall with R21 insulation plus an R2 continuous exterior insulation, for example. Or for the metal stud wall, you could do a 2x6 metal stud wall, 24 inches on center, put the cavity insulation in there, but now you'd have an R12 continuous insulation. So your design build team can, price out the cost difference and the detail difference, and also consider if they are going to do a trade-off with the wood stud option and not put that R2 on there and try and trade it off with something else. And then I just wanted to point out what a big difference climate zones make for all these requirements. That's why climate zone is the first thing you look at, because if this project were in our Monterey Bay area, for example, climate zone 3, we wouldn't really be having this discussion because they'd probably just go with a 2x4 wood stud wall filled with an R11 and kind of be done with it. Now, for the trade-off, then you can look at this computer modeling method and have someone, or your mechanical engineer or the architect in-house or third-party consultant might run what's called the quote-unquote Title 24. And with Title 24, there's 3 metrics we look at: efficiency, how efficient the building is. We have a metric called the total. That includes your photovoltaics and batteries. And then we have a metric called source energy total. Also includes the photovoltaic and batteries, but that source energy is actually a metric or a proxy for carbon impact on the amount of impact it takes to produce the electricity that goes into the building or produce the fossil fuel that goes into the building. Or it's also a metric that that hits on the carbon impact of burning fossil fuel at the building site directly. And then these little footnotes down below. And if compared proposed design compared to your standard design, if it's positive, so your proposed project uses less energy than the standard design, you'll get a pass, pass, pass. The whole project passes if you pass all 3 metrics. And then if this particular excerpt from CBEC Com software includes a little footnotes to remind you that the total compliance efficiency, both the total metrics include your photovoltaics and your batteries. Now, non-residential projects use TDV, time-dependent valuation, as a metric. Residential has a slightly different metric. And just as a heads up, we're not going to go into it in this course, but we have other courses that you can take. Single family under 2025 is changing their metrics slightly, but the concept is still the same. Standard design, 3 things: efficiency, total, and a source for carbon proxy, and you compare it to your proposed design. If all 3 pass, you pass. That part conceptually hasn't changed. So what this can look like, and again, I don't need to go into it all in a lot of detail, but just kind of understand the energy code. We look at 3 kind of big buckets when we're looking at these trade-offs. One is what's called the regulated loads, and they can be traded off with each other. So these are the things that are using energy in the building that include your space heating and cooling system, your indoor fans, your hot water, your interior lighting. And then we've got this other bucket, which is the photovoltaics and battery requirement, sort of the energy you're creating on site to help offset those regulated loads. And then for commercial projects, and you can pull the same information on residential projects if you want, is you can get an idea of what's estimated for the rest of the loads, or the rest of the energy use that has to do with plug loads or receptacle, and to give a bigger or better idea of what the overall impact is of your building. So maybe you could use that information to help size your photovoltaic system if you want to go beyond the code requirement. So there's a standard design for each of these. There's a proposed design that you're creating, and then we look at the compliance margin, and this often gives us a window to know where we can make improvements if we need it. So we look at that compliance margin, and if we see a negative sign, it means we're not quite meeting the standard. If we see plus, positive numbers, that means we're exceeding the standard. So these things can be traded off, and then overall we have a positive 2.93 compliance. And then we look at our photovoltaic and battery. In this case, we size the photovoltaic and battery to be a little bit bigger than required. And that gave us a positive number. So overall, our project passes. And then source, we do the same thing. And here's where it can get a little bit tricky. And this often comes down to if you're burning fossil fuels in site, but the same idea. You look at that compliance margin, the negative number means under standard, positive means we're just exceeding the standard. And in this case, our efficiency compliance is actually negative. So under source energy, we're not quite making it, but we oversized the photovoltaics and the batteries just a little bit. And that was enough to boost us over the finish line. So this project complies. So that's how you can use those trade-offs. And that's what your design team is doing for a project in terms of the energy code. And then so that's kind of gives you kind of that idea of how that energy code sort of fits into the process and the trade-offs we're looking for. And then when it comes time to getting ready for our 2025 building code, I pulled together a few slides here where these are things that I think folks might want a heads up on what's coming up for the 2025 energy code. But before we dive into that, I see, oh yeah, great. I see a few things in the chat, like Andy is telling folks, good, reminding folks, ESS is for energy storage system. And in the 2025 code, you're going to see it written as BESS, B-E-S-S. Some people just say BESS, and it means battery energy storage system. And then CI for continuous insulation, and it's typically at the exterior. And then feel free to put any questions in the chat, or, let Andy know you have a question or a comment. And then I'm going to kind of go into what we're seeing for 2025 coming up, just to give you all a heads up. There's some new, for example, prescriptive requirements, just as California marches towards a cleaner grid, more on-site photovoltaics and batteries, and heading towards all electric in an attempt to reduce air pollution and burning fossil fuels in a way that's not so efficient. And we're often dependent on outside entities for our natural gas. California imports an incredible quantity of our natural gas. I think we only have less than 10% that we have here in California, and about 90% is imported. So California wants to be energy independent. And so California has a long history of looking at independence, kind of leading the country. And this is under all kinds of political spectrum, governors running California. Our state has prided itself on energy independence. And so we're continuing on that path. And so part of how we do that is looking and embracing energy efficient technologies like heat pumps. So there's going to be some new prescriptive requirements around that as the technologies evolving. And so one of the big areas that shows up in the 2025 code is more helpful mandatory requirements for heat pump water heaters. And I say helpful because we've been following the installation of heat pump water heaters for a while. And since it's relatively new technology, the installations have been less than perfect. And when the installations aren't done properly, it gives heat pump water heaters kind of a bad name. And there's really nothing wrong with the heat pump water heaters, but there are a few things people need to know about the installation to make the installation and the customer experience positive. So as a result of that, now there's some new mandatory requirements for how you install the heat pump water heaters. And that includes volume of space needed for the heat pump water heater, a little bit more requirements on ducted systems and ducted options, and more information on where the ducts are installed. And the reason for this is because heat pump water heaters, the heat pump itself extracts warmth energy out of the air, and it pulls that through a refrigeration cycle. It pulls that heat out of the air and puts it into the tank of water. So the appliance itself needs access to a certain amount of volume of air so that it doesn't accidentally overcool the air and become less and less efficient. And you can duct the heat pump to outside air sources to eliminate that volume, but the ducts need to be of a certain size, etc. So this is going to improve the performance, and that's why there's some new mandatory measures. Also, the electric ready in new construction, it exists right now when gas appliances are installed, because you can install furnaces, water heaters, cooktop dryers, etc., that do burn natural gas. That's legal. And then if you do, the idea is to remove the cost barriers and to set it up so that anyone else in the future can easily change it over to an electric appliance. And then kind of the update is in the multifamily code. There is a little more detail on how much space you need to reserve for that future heat pump water heater, because they are a few inches larger than a lot of standard tank electric or gas water heaters. And that has been one of the issues that has come up that we see, is people don't realize they need just a few more inches space for these heat pump water heaters. So heads up to the architects, and also to any of you working with ADU plans and over-the-counter permits with that. It's one of those things where you need to see if that, it's not a code requirement, but it's one of those best practices. You could improve the performance of everything if there's enough space for that appliance. With multifamily central water heating, now new in the 2025 code, there'll be electric ready for central systems. So gas water heating is allowable. You could still have gas on-demand boilers like these Lochnavar units in this big multifamily project here I took a picture of. But if they do install a system like that, now the code says you need to actually allocate enough physical space, or at least show where the heat pump water heater tanks would go, where the compressors would go, your strategy for how you would do it. And it includes practical things like condensate drain receptacles, etc. And then there's some new code requirements for electric ready on commercial kitchens. So I thought this was pretty interesting. And then as a result, the code now includes kind of defining. So we're all on the same page what a commercial kitchen is, and the difference between quick serve commercial kitchen, institutional commercial kitchens. And there are exceptions to this, but now you'd have the electric infrastructure to be able to have induction cooking on a commercial scale. And there's been some updates on solar and battery in the high-rise non-residential requirements. Right now, under the 2022 code, a lot of occupancy types do prescriptively require PVs and batteries. And then under the 2025 code, some occupancy types were added and some have been increased. So restaurants, for example, had a dramatic increase in the PV battery requirement, which kind of goes hand in hand with those, electric ready on those commercial kitchens. Okay, so that's kind of the highlight of upcoming 2025 code changes. I'm going to go through some resources that are available to everybody. And I was just wondering if there were any questions or any comments or anything that Pam or Andy wanted to ask about or chime in on.
I think there's a couple of items that I'll save for the Q&A period at the end, maybe being able to talk a little bit about some of the glitchy spots that we find for compliance that comes up in Code Coach. But I think sharing the resources and making sure folks get all of that first would be great.
Okay, that sounds good. Okay, well, first off, the California Energy Commission. That's a really good site for all things about the energy code. So, but what I've noticed is the California Energy Commission periodically changes and updates how they link to the resources. So case in point, I thought I had my slide all ready for you guys, but I was like, well, I should just double check to see if they've changed the website recently. So this week I went on, I was like, oh, look at that. They changed the location of some of these links. So I just want to give you a heads up that if you ever go onto the website and something isn't there, or in the future, it's different from what I'm telling you now, don't be super surprised and don't get too confused. Don't get too upset. You can always reach out to us as code coaches, but also snoop around on a bunch of the links. But currently, right now, if you want to get more resources, you'd take a look at the rules and regulations pull down. And from there, you would go to, for example, for the buildings, go to building energy efficiency. And then that's going to take you to this landing page. And what's different, if you haven't been on the site recently, what they have now is their energy code support center, where you can get a lot of resources. But they also have the links to the energy efficient standards as a popular link. And if you go there, you might lose the fact that you needed to scroll down on this page to actually get to the Energy Code Support Center. And it's the Energy Code Support Center that also links you to that climate zone finder I showed you at the beginning, fact sheets, frequently asked questions, forms, etc. So just scroll down and take a look at that other link. Okay, also, if you go to the newsroom link, there's a Blueprint newsletter. And this Blueprint newsletter is published quarterly. It's super helpful for topics in the energy code that are coming up. It's got some common question and answers for code interpretations, and it offers a lot of clarifications on code issues. So I think this is a great publication if you're really wanting to dig in deeper and keep up to date on the energy code. It's worth having the blueprint emailed to you, or go check it regularly. And case in point, this most recent edition is the 2025 Energy Code Single Family Summary of Changes. So they just kind of list a whole bunch of those changes in one point. So it's a great summary. But also, I love the fact that given everything we're learning about heat pump water heaters, someone on their staff went to the trouble to draw a diagram to be more clear about what they were talking about when they had the requirements now for that volume of space needed or the ventilation area needed for your heat pump water heaters. And just FYI, we do offer and will be offering more information on heat pump water heaters and that installation as, CCR REN, rural REN gets going. Cheers is the registry. So California, all of our Title 24 Part 6 residential, low-rise, and single-family projects are registered, and this ties back into the jurisdiction to pull from those registries. And it's also where your HERS rater, soon to be called ECC rater, can go and find your project and take care of the rest of the paperwork associated with the on-site inspections. And so cheers, this is where we go to register the projects, but also it's a good resource for just learning more about the energy code and kind of what's required on the HERS side of things. Energy Code ACE is another great resource. Energy Code ACE is contracted with the California Energy Commission right now, and they produce the prescriptive forms so you can follow along and answer a set of questions, and it'll fill in the prescriptive forms for complying with Title 24. They also have their ACE resources section, which has a lot of fact sheets and trigger sheets and checklists. So that's a, another good resource, kind of sidebar there. And then this other resource was for the Title 25. And the reason I mention it, especially for the folks that are in the planning building department, a lot of times people believe that if they're doing factory built housing, that they don't have to comply with Title 24 because factory built housing falls under Title 25. But there is a factory built housing handbook for the local enforcement agencies, builders, etc. There's also factory built housing sort of fact sheets that go over this. And what I want to point out is that they do in the handbook, especially explicitly spell out that, yes, even the factory built housing has to comply with Title 24 Parts 2, Part 2.5, the electrical code, mechanical code, plumbing code, and the energy code, and yes, the Cal Green code. And if all of this leaves you with more questions, then please reach out to us. Go to our website, ccrren.org, Codes and Standards Program. Click that button. It's going to bring you to our Energy Code Coach, and you can complete our intake form. And it looks like this, and a code coach will be in contact with you. And we are happy to answer all of your code coach questions. So please reach out to us. And with that, I'm going to hand it back over to Pam, and then we can have a few minutes for questions and answers.
Great. Thanks, Jennifer. It was a lot of great information. So I just wanted to let everyone know that we have some upcoming courses, the overview of HERS or ECC compliance, Introduction to CalGrain Code, and Introduction to Zero Net Carbon Design. As Andy mentioned earlier, we're just in the process, but hope to be able to have the continuing education for AIA and ICC all worked out in the future so that you'll get those course units that you'll need. And as Jennifer mentioned, any type of coach or any type of code question, you can go to our code coach service on our website. We're in the middle of redoing our website. We just kind of put something up quickly to get ourselves out there, but go to ccrren.org, and if any questions can go to info@ccrren.org. And with that, I'll turn it back over if we have any questions. Oh, I'm sorry. I am going to right now put a link in the chat for a survey. We'd really appreciate if you could go ahead and take just a couple of minutes to fill out that survey. It gives us great information and tracking metrics, etc. And we'd love to hear from you if there are different topics that you're interested in. As Andy mentioned earlier, if you are an AHJ and you have a team that you would like specific custom energy code training to, potentially even in person, we are certainly open to that. We are here to provide you with, code information and energy just in general. It doesn't necessarily have to be specific to code, but energy measures that are useful so that we're ensuring that those get into our built environment or retrofit into our built environments. So with that, I will turn it over to Andy or to any questions that you might have for Jennifer or Andy.
Great,
Thanks
thank
so
you so
much
much. And while you're filling out the survey, we'll go ahead and start the discussion. If you need to jump off, feel free. We understand everybody's trying to, get their days done. If you have a question, we're a small enough group, you can just raise your hand. Jennifer will stop sharing, and so we can see each other, and you can put on your camera if you'd like. Or if you would rather just type your question to the chat, that's fine too. Jennifer, while we're maybe generating some questions or discussions, comments, if folks have kind of stumbling blocks that they've experienced either on the submitting plan side or construction side or the building department side, we'd love to hear about it. And Jennifer, I thought maybe you could start with talking about some of those HERS measures and the verifications, because they do evolve over the different code cycles. It's been a little bit hard to for folks to keep up. So what's the what are the general mandatory HERS measures that makes you have to bring somebody on site? And what are the optional ones that you could still use as trade-offs in the performance method?
Yeah, that's a good question. So a lot of the things that so residential, for example, let's just start with the residential section. Something called QII, so quality insulation installation. So there's a couple of times during the construction process where the HERS rater will come out and look at the air sealing and look at the insulation quantity, but also the quality, how it was installed. And so like last time I was on site with our local HERS rater, Paul, we found, it just depends on who's doing the installation, but we look for voids and gaps. So for example, there was some blocking that needed to be done between the stud bays under a window. And so the guys that came in and did the insulation, they cut the insulation bat short. So it turns out there was a good like 6 inches of wall space that you couldn't see visually until we reached our hand in there, that just was lacking insulation altogether. So that was like, okay, so we have a few things like that. And then Paul will, they'll have the folks come back and do it properly. But oftentimes we like this integrative process that Andy was talking about. We highly, highly recommend that it becomes a team effort. So the HERS rater will often meet with the insulation contractors beforehand and just give them a heads up that that's all the stuff he's going to be checking. So they'll do it the first time, things like that. And then for multifamily, for example, under the current code for multifamily projects, in lieu of doing compartmentalization testing, which means like a blower door testing, it means checking how much air leaks between each dwelling unit and leaks to the outside. In lieu of doing that testing, the mechanical engineer could specify, or the architect could specify, balanced fresh outside air ventilation for the unit instead of like exhaust only, like a bathroom exhaust fan being the only way you get ventilation. Could do balanced ventilation. So air from the outdoors comes in through one fan and then another fan exhausts that quote unquote stale air outside the unit. Well, 2025 code, they changed that requirement. So now compartmentalization testing will be required anyway. And you're going to want to do balanced ventilation anyway. So that means there'll be a little bit more work for a HERS rater, for example. But that's just two examples. And then we'll I'm sure all this will get touched upon in the upcoming training.
Yeah, in a couple of weeks. Great. Anybody else have questions? I know we're coming up on our time right here. I could always keep peppering you, but maybe we'll let
I
folks.
can always keep talking. Oh,
Great.
ask me if I like the energy code. Yeah, I do.
No, it's a lot to it. All right. I'm not seeing any other questions come in, so maybe we'll let folks go. Thanks again for coming, and hopefully we'll see you at the next class.
Okay, and
Thanks,
Andy, I will just
everyone.
add that we will be sending an email with the presentation slide deck, and look to our website for the recording to be uploaded in the next week or so. Great. Appreciate
Awesome.
everyone's time.
Thanks, everyone.
Thanks for coming out.
Thanks, everyone. So glad you could join.